Hello everybody and welcome to Handmade Hero Show. We code a complete game live on stream. We are going to do some debugging today. We basically made the entirety of our font utility, which is just designed to extract a font from, a true type font or something that exists out in the world already. And this is supposed to take that font and extract certain of, specific glyphs from it that we specify, and produce PNG files that can then be fed into our art package. It's not our art package, our art pipeline, exactly as if they had just been created by an artist, while at the same time producing an HHT file that's got all the data like the horizontal advance table and the number of glyphs and the name of the font and stuff like that, so that we can kind of automate the process so that no one has to manually do all that work just to get a font into the game. It's the last thing we really don't have in our asset pipeline. We have streaming sounds, streaming sprites, and this is the one thing we don't have a way to build automatically through the game pipeline. We had done a long time ago when we first implemented fonts something that packed HHAs directly. We don't really want to do that anymore. We want just a single art build that has everything with no command line utility required, and we're pretty close to that, so this is really the only thing we've got left. I'm going to go ahead and get started on that process. We pretty much made, like I said, the entire utility. The only thing that we didn't do is figure out how to write a PNG file out, because we'd never done that before. We sketched the beginnings of that, but we didn't quite get it working, and so what we need to do now is get that actual PNG export process into place. And so our goal here is to take this utility. You can see here, this is the HH font utility. Take this utility and work on this one part just at the very top. It's just a simple function called write PNG. And what we want to do there is get it writing out the actual PNG data, so that when we read the PNG data on the other side, we get the bitmaps for the font. Now, we already checked this code to make sure it worked properly. What we did is we wrote out a bitmap version, and we knew that that worked properly. So we know that the pixels value here and the width and the height are correct. So we know that we aren't dealing with like corrupted data coming in. And that was an important step, because since we have no idea what we're doing here with writing out this PNG, we're just making it up as we go along, looking at the spec and looking at our reader and trying to match the two. We don't want to start in a situation where we don't even know if what we're writing out is correct. So we definitely wanted to do that step, and we did that step. But now we have to figure out about the rest of this stuff to figure out like how we're going to actually, like what we're writing out incorrectly, such that our code doesn't work on the other side for reading it. And then we have some extra work to do even on top of that, which is to say that our code that reads PNGs doesn't bother to check things like the CRC or whatever. Therefore, we should be able to get our reader working first, because it doesn't require the data checks to line up. Once we want to take the extra step of having these things be loadable by some third-party art tool like GIMP, that will require us actually making something that does do correct CRCs. There's two CRCs. Martin's reminded us during the pre-stream that there is an Adler32 CRC stuck at the end of the zlib stream as well. We haven't done that either, and so that needs to be stuck in there. I don't know. I don't think our reader... Does our reader do that? I don't think our reader ever looks at that. Yeah. So our reader doesn't care about that, so we should be, I think, unless I'm misremembering some other thing, we should be able to get our reader working first just by concentrating on exactly getting the stuff that we care about, which we should be pretty close to. We should get that done, and then from there we should be able to add back all the stuff that we would need for a reel to be a correct PNG, not just one that only supports our one reader, right? Because I would like to go the full pull there. Okay, so the first thing I wanted to do today is just remind ourselves what PNG filter reconstruct does. So if we look at PNG filter reconstruct, and I just come in here and look at it, I just want to make sure that there's nothing weird that happens during this process. You know, it doesn't look like it. I'm not sure what prior row advance was supposed to be. Oh, it looks like... Oh, I see. That was just something for us, for when we were doing these more advanced filtering things. So, you know, I mean, writing out 0 case, it looks like it's just copied directly. Let's take a look at what happens in the PNG filter here right before then. Or, sorry, right after then. When we write things out, what do we actually say? So we say pixel op invert and swap R. So what does pixel op invert do? It just flips the thing upside down. And swap R just swaps these two. So thankfully, when writing out the bitmaps, we're not really touching the values much at all, right? There's really nothing particularly weird going on there. So it looks like this stuff should be fine. What I do want to do really quickly is just make sure test PNG is still working, because for all we know, it might not be. So I'd like to take a PNG that actually we know is good and make sure that it can export that, because I don't want to assume that we're writing in something incorrectly based on test PNG until we verify that test PNG is still working, because we haven't run it in forever. And who knows, maybe we changed something and broke it. We don't, it's not really utility. It was just for us developing our PNG reader. It's not something we actually consider important, so we don't maintain it or test it at all. It's just a throwaway routine. So we should double check it just to make sure we didn't break it, because we would never have known, right? So let's go into our sources directory and let's take a look at the intro cutscene. I'm going to go in here and take a look at the art directory, and we'll just take one of these at random. Right, so, I don't know, here's shot16. Oh, let's take Santa Claus. So, let's do shot42.png. And what I'm going to do is I'm just going to say that wbuild... oops, that didn't work. Wbuild test PNG. And it will tell me what to do. So, file... Okay, so I just need to actually put the file names in here for the PNG, which is this. And then I'm going to do shot42 color.bmp and shot42 alpha.bmp. And let's see what happens. So no errors. Looks like everything loaded okay. If I go back to the temp directory and look, looks about right. That's what I would expect to see. So everything seems fine there. Nothing particularly unusual. So it looks like test PNG is in fact working. So then again, let's go ahead and get the font dumping procedure kind of into something that we can call repeatedly. So if I go into the Handmade directory, I'm sorry, into the temp directory and into the font directory, here's all the stuff we've got. You can see all of the PNGs that we're dumping here. And these PNGs are, you know, not working properly, which is what we would expect because we know that the code is broken. So let's make a thing that dumps and then runs this. So one of the things that we would expect maybe is like the 0114.png. Well, I don't know, maybe, or I don't know which one of these we should do. I guess let's try this one. I don't know, what's 89? What's decimal 89 in the ASCII table? Decimal 89 would be the Y character. Sure, that seems fine. So let's suppose we want the Y character. That's the liberation mono dump. So if we wanted to make this work, we would say hhfont. Hhfont. The TTF file name, in this case, actually, let me put that in here from here. There we go. So this is the TTF we want to extract. That's the name of the font. That's the size. We then have to supply the char set, which in our case is test. We have to supply the dest HHT, which we don't really care what that is, but we can call it test.hht for now. And then the dest PNG directory, which is temp font. That will produce the entirety of the font and extract all the font bitmaps and all that stuff. We then want to run our extractor, so that's build test PNG. We want to pass one of those in, so, oops, not that. So for example, one of these, and we know that we want 0089.png, and then we will do oh, we're already in the temp font directory, so I don't know why I specified all that extra stuff, but anyway. rgb.bmp, out alpha.bmp. So running those two things in series, like I did there, should run both of them, and you can see it doing that. So it looks like we forgot, after the extracting, we forgot for the font. A carriage return. Yeah, we did. There we go. All right, so if I now run this, I should get both of these things happening. There you go. So it first extracts the font, and then of course I use this to like run two things on the batch line, on the same line, two programs. Then it does the extraction, and you can see it talking about it here. So it says, all right, there's the width, height, bit depth, color depth, compression method, filter method, interlace method. Then it says, okay, here's the IDAT. I don't know what the 749 is, but then it says, okay, let's examine the zlib headers. Here they are. Let's decompress. Looks like we supported it. Let's write out both of these bitmaps, and then we're good, right? And so then we can come over here and, oh, suddenly it's working. We haven't changed anything. What happened? All right. So I guess we have gotten to the point where it's sort of working. We just haven't quite gotten it all the way there for other people's utilities, I guess. Who would have known? All right. So that looks like what we want. The only thing that we don't have there is the upside downness of it. We have to decide what we're doing with that. So we're flipping, the image is getting flipped there, right? And so when we export that PNG, we may need to do an inversion because the PNG, you know, we've got something that's like top down or something, right? But the PNG wants it bottom up, or however that's working. So we may have to do a flip in place, but looks like that's about all we would need to do to get that working, because otherwise it looks like we've got the correct stuff in there. So if that's the case, then, well, and there's a couple other things we need to know about as well. Let's just double check something while we're still in the mood to do so. So if we look at when we load the PNG, here, right, we've got the PNG comes out, we get those final pixels out. You can see here we're not doing any like gamma correction or any of that stuff. So there's no like pre-multiplied alpha or anything in here, I don't think. So if we go into the code inside the asset system, where, oops, sorry, like the importer, that's going to actually grab an image out and use it. So, you know, if we look at what's happening in, say, extract image, you can see here that we're doing a bunch of work to do the like when we load the PNG, right, we're doing our own unpack, convert sRGB to linear, multiply, convert it back to sRGB and pack. That means we expect these to be gamma corrected, but not alpha pre-multiplied. And so what we want to do is make sure that our HH font extractor is not pre-multiplying the alpha, because that's going to get done at another time. So if you look in here and load glyph bitmap, what you can see is we are doing that work, right? You see that happening there? So it's effectively doing a pre-multiply of that alpha, but all we really wanted to do was just write out the texel as 225, 225, 225, and then write out the alpha as gray. Like, that's all we actually wanted it to do. Make sense? So we don't really want the sRGB linear conversion or the multiplication or any of that stuff. So this piece of code really just wants to look like that, so that it's always going to just produce the exact texel. Since we know that the gray level here, we don't actually need to do any of this because the gray level is the gray level, right? And I don't think there's any need to adulterate it because it's just whatever the linear gray level actually is. What we can do is just say, okay, instead of doing any of this stuff, right, we can just actually pack this directly. So we can say, okay, take the pixel, do the AND with OXFF to find out what the gray level is, right? Like so. And then when I write this out, what I really want is I just want effectively the same routine here that was, well, not routine, but the same thing that was happening here, where we pack the gray up in the alpha channel. So, you know, this, right? But the rest of it should just be white. Right? Because we want the alpha to be controlling here. We don't want to actually do anything else with it. So that just packs pure white in and then the alpha value. And that's it. That's the end of it. Because again, this is effectively a monochrome bitmap. So that's what we actually want to write out. So I'm going to write that now and make sure that we can get a reasonable image out of that. So what that should produce when I run this now is a solid bitmap for the RGB, which is just white, because there is no data contained in it at all, right? And then the alpha should be the Y shape, and it should be properly alpha. No sRGB shifting happening here or pre-multiplication or anything, and that does look like what that did. So now I think, although we need to do a flip, and we could do that here, I suppose, if we just invert these two. Now, looking at that, it looks like we're already doing that. So do you see how dest row is going backwards and source row? Although, actually, wait, they're both going backwards? Okay. What? Why? All right, I'll be honest, I don't understand why they're both going backwards. That I'm not going to ask. But let's suppose that we wanted this to not be flipped anymore. We would do that so that now the dest row is starting at the top and going down instead of starting at the bottom and going up, right? And so if I don't know why I closed that directory. If I look at it now, we should get the Y in the correct orientation, and it is. Although I'm a little weirded out by the shape. I don't understand why we've got like empty area down here. And also I thought so that looks like it's off by 1. I feel like it should have been yeah. So I think this is you can see it doing it too. It's supposed to skip one line. Because it's supposed to leave 1 pixel of padding all the way around the font. That was because we want our textures to be padded with a blank row for sampling purposes, right? So really, we do want 1 row of pad there. So that is the actual code that we should do, because that leaves the row of padding. And now that instead of 2 on the bottom and none on the top, there'll be 1 on the top and 2 on the bottom, right? So that's good there. And you can kind of see now we've got that nice 1 pixel border, which is what we wanted. All right, so we're now effectively done with the part we actually need. So we could ship this now if all we cared about was that the code for extracting the font can be read by our extractor, right? If that makes sense. So we want to do that. But when we actually do this here, I want to be able, these ones that are output by our bitmap routine, for example, are compliant with off-the-shelf tools. So if I read it in, right, I can edit the bitmap for any of the BMPs we write out. But these are not. Like these PNGs, although we could read them, nobody else can read them because we don't comply with the spec to a complete enough state where they could actually read them. So instead, if we try to get one of our PNGs, we get toasted, right? So what we want to do first is we want, before we go any further down that road, is we want to actually get our PNG writer working correctly so that it doesn't have this problem anymore. I would also say that perhaps one thing we could do here is loft the PNG writer up into the PNG reader, because why not? Here's our PNG reader, parse PNG. Why not just have this be shared? That way, if we want to write a PNG out from our game, we can do that too. So let's stuff that in here, like so. And then up here where we've got that parse PNG code, right? This endian swap can now get moved back into here because it's only used in this code. And then the parse PNG header there can be accompanied by a write PNG that just has that code in it, right? All right. Now, I take it back. Nope, I don't want to do that. So this is a little bit squinky because it needs some way to write stuff out. And so that does seem less good. I suppose what I could do here is just have a stream that allows me to write it out. That doesn't seem terrible. Yeah, I mean, looking at this, you can see like we just have a penned chunk, and so that would probably just work, right? So we could do that. So maybe what we'll do here is instead of write PNG taking an output file name here, what we do is say, look, give me a stream, and we'll just write it to the stream. You know what I'm saying? So here we would just say, all right, here's the stream. Same thing we did before. Then we don't do this code, right? We don't want to do that. Instead, what we do is just output these chunks. So in here, everywhere that we were doing an fwrite, we can just have an out chunk or like something like that, right? So like just an out data, right? Something like this. And this exact code here, all it would do is say like, what's the count and the memory that you want me to write, and then I have a stream here that I'm actually writing it from. You know what I'm saying? And so that would just involve allocating something from the allocator, right? So from this memory arena here, that would just require us pushing a block. So there'd be like a push size call here. This would actually be called data. So the dest memory pointer there would be where we would write it to. We would write count size, and then that. Do we have a push copy call? We do. So if we actually want to do this, we could just do a push copy, and that just takes the count and the data, pushes it on here, and gives us back the result. So there's a void star that would come in, that would be returned as whatever the out data was. So yeah, if we want to do that, that's pretty simple. Here's the result. We push a copy of the thing that you push in, that you put in here, and then we append that chunk. Now we may want to do this a little bit differently. I'll show you in a second. But that's this call right here. That just gives back a stream chunk. We don't actually care about the chunk. Oh, and in fact, yeah, in fact, that does everything for us. So this is really just, hey, here's the dest. There's the count, and there's the result, right? So this is like really concise. It's just that. Oops, I guess you can't do that though, because push copy is two things. So yeah, there we go. And so if we want to do that, that all works exactly the way we would expect. We can also do a thing where if we wanted to, we could do this slightly differently, right? We could say that there's a void data equals 0 here, so that if you don't pass an actual thing to copy, we will just reserve the size, if that makes sense. I don't know if I actually want to do that. I might want to do this instead. Right? So maybe we'd do something like this, and then you would just do a push size call and not pass any data, right? So that way you can reserve some space, like something like that, and maybe this is out copy. That should give us what we need. And then instead of an fwrite, we can just call that. So now, from now on, we would just do that. I also feel like maybe one thing we would want to do there is pound define. Is pound define an out struct that basically says, okay, if we want to write a type out or something like that, we could just say, look, pass us the stream, whatever stream you want to write, and then pass us the instance of this thing, whatever it actually is, and then we'll just write that out. Maybe outstruct copy, I don't know. I'm not quite sure exactly what that should be called. But then what it would do is it would call out copy on the pointer to whatever that thing was, using the size of whatever that thing was, and the stream that you supply. You know what I'm saying? That seems like a possibility. Another thing would be just a regular outstruct with a type. And so that would just be out size, and that would be stream size of type. And that would give you back a pointer to that thing, like so. This would as well, actually. So I think that's probably useful, and we'll see. So that gives me all of the tools I need, and that means we can actually write this a lot cleaner now than we were. In fact, I kind of like that. So for the PNG signature, we would probably leave it roughly the way it is. So we'd say like outstruct copy, you know what I mean? Although, actually, I think this just wants out copy. So this would be, you know, there's our stream. This is the size, and there's the pointer, right? But the rest of these would be, would save a copy kind of nicely there if we just did it like this. So we say outstruct PNG iHeader, and that writes to the stream that amount of space so that we can then just go like this. Make sense? Yeah. So there you go. So we can just do, I think, everything that way and make that a little bit cleaner. So these would just be like, okay, you know, do an out. Well, actually, these we write multiple times, it looks like. So if we want to do that, again, still really easy. We just do an outstruct copy. Yeah. So we can do it this way. I don't know which one we like better, but here's another example. So then we would just say, all right, we want to do an outstruct. So here's the stream, there's the struct, right? Again, it makes that look a lot nicer. So we're like, put out the header, write the iHeader part, then put out the footer. The footer in this case, yeah, again, we kind of want to actually have some way of getting the CRC properly, which I think there's actually some interesting ways we could do that. So I'm not sure exactly how I feel about that, and I almost kind of want a thing that just outputs the headers and footers for me a little bit differently, but I don't know. We'll see. So that's how that would look, right? And then as we kind of go down here, again, same difference. So I think I probably want to leave this roughly the way it is. Yeah, just looking at that. So I don't know, maybe this was a bad idea. Maybe we want to leave it essentially unchanged. So maybe the better way to do it, just having looked at it, it's like, not great. So maybe we want to do it so it is exactly this way, and it's we just replace these with outstruct copy. And again, it still is nicer because it's just that. But I think we do want to leave it roughly that way. That code looks a little bit easier to deal with, right? And so then again in here where we're doing the f writes, it's just outstruct copy. And then we're just passing those, and oops. I need a key that's like delete until the next enclosure to add that someday. That should be that. Oops. Okay. So this is an outstruct copy as well. So is this. Oops. And I think this right here is wanting to do, well, so this is an outstruct copy. But this is actually just a regular out data, right? That's just like a regular out copy. Yeah, that's this. And that's trying to do something this big at that location, right? So I think that should give us everything we need. And now we just have to do type undeclared identifier. Oh, yes, that doesn't exist. There we go. So now we just need to take a look at that, this code here and say, how do we actually write a file from that? You know what I mean? Because it's going to produce a stream, but we don't actually have any way to actually use that stream, right? Like we don't actually know how to actually produce it, right? A file from it. But now we can call write PNG anywhere we want, and it produces basically a stream that just has all of the blocks ready to go. So if we take a look back in our test PNG, you can see in there we sort of have the way that our test PNG program was doing memory, right? So you can see when it actually creates the platform shim here, that's how those allocators were working, as they were calling through this platform API global. So we should be able to do literally that exact same thing inside our HH font utility. And again, it kind of looks like someday we want just a common thing that everybody can share. Because this code is exactly the same, right? So if I take this code and just stick it here, like that is exactly what we want, which kind of tells us that that code should probably be shared, right, between these utilities. So now if I actually run the dump stream to CRT side of things, that is what we would actually call. And so out here where we do, this is the place where we actually do our writing of this stuff in the after load bitmap, we actually call that to write it out. And so right here where we do write PNG, what we want to do is we want a stream here to exist and actually do that writing, right? We want to make that work. So in order to do that, what we would do is just say, all right, I think, let me see here. I think we just need to include the same stuff that we're including here. So we want this exact thing. I believe. Yeah. And so now we basically have the ability to do all the same stuff we were doing before. So we can, you know, make a memory arena and use it and all that nonsense. And we can then, you know, write the PNG to a temporary buffer and then dump it to the CRT. So the actual call here where we do dump stream to CRT, if we go down to where we were doing write PNG, the write PNG call is now two calls, right? It's first we write the PNG to a stream. So we've got something here that's going to create that. This is going to be like the PNG stream. And then we would just say like, oh yeah, you know, the PNG stream gets written out to the PNG out name. That actually has to be opened, right? We have to do an actual like, you know, test to see whether we can open it here. And produce a file. So this is the PNG out file. We would say fopen. We'd say, can we actually get it? If we can't, then we would print an error, just so they know that the font extraction failed, or at least partially failed. And that is the PNG out name, right? PNG out name, write binary. So that is what gives us the file that we can write to and that we will dump to. Here in write PNG, we just need the stream. That stream, I believe, there are easy ways to do it. You can see it right here. So we can say on-demand memory stream, which is just something that's going to like allocate whatever it needs to get the job done. And we don't need an error stream for that at the moment anyway, because we don't actually have one. We could produce an error stream here eventually if we wanted to. So really all we need to do is create the memory arena. The memory arena in this case, I think can just be nothing. We don't have any requirements for it. So we can just do this. And then when we're done, is it clear? I don't remember. We can just free the memory. So I think that's all we actually need it to do. This is an address of here. Other than that, I think we're good to go, right? Yeah. So that should give us the ability now to share that code so that anyone who wants to write a PNG in the game can also do it, which I think is good. Like I want that to be something we can do eventually. I'm going to delete all this now. And see if we can get the writing working again. Yeah, there we go, right? Because we got to make sure that this code works properly. So let's debug that and get that working now with writing the PNG this way. And then when we're done with that, we will start on the process of oh, that's weird. Huh. I wasn't expecting there to be a bunch of files there. So let's make sure we get that working, and then we'll go ahead and finish up the like CRCs and making sure that the stream is nice and works with all of the stuff that other, you know, not our reader, but other readers, industry standard readers, expect to have in the stream so that we're more spec compliant. All right, so I guess I want to run actually HH font. And I want to make sure that we have this stuff in here because I don't know if we do. Yeah, we don't. So we need two things here. We need wtemp font test.hht and then wtemp font, right? And I'm going to save that so that we don't have to do it next time. So if I run it, we should crash the PNG writer. What just happened? I guess that's not what will happen. Let's try the exact command line that we have that was broken, because apparently it's sensitive to what specifically we were writing, I guess. Why am I not crashing? Oh, okay, it's test PNG that's crashing. It's just because our file is busted. Okay, well that's fine. We still can do the same thing, which is figure out why our writer is not working properly. Okay, that's fine. That's yeah. All right. So let's go back in here and let's take a look at what happened. Okay. So if I take a look at the stream stuff here, so that's this code. We're creating a temporary arena. By the way, is X13 Pixels with us today? Probably not. I noticed there's a bug in 221 that when you when you run to cursor, it switches your focus to the disassembly window, which makes stepping happen in the disassembly window by default, even if what you started to run on was this window, from what I can tell. So like here I am in this window, I run it because disassembly like wasn't open because the disassembly window like closes, which by the way, I don't know why the windows go away in this mode. I feel like they should stay, but you know what I mean? So it shouldn't switch to this because then you constantly have to click back here for no reason. That's a sort of minor issue. Anyway, so we create an on-demand stream, we call write PNG, and so we start by doing all of this stuff, and we are going to copy these things into the yeah, we're just putting these things into chunks, right? So there's the count is 8, and the data is, you know, the PNG header, I believe. I don't know if we can actually look at what the PNG header says here, but, you know, something like this. Probably just a signature we can't read. Yeah, there it is, PNG, sure. So we're going to write that out. And so what's happening here is we get the result out of this thing, which we, you know, in theory copied, did a push copy into the memory for the stream, and then we're going to do an append chunk. So that's just going to put that chunk onto the end, right? So in theory, it should just produce a nice chunk struct that's got exactly this stuff in it, and that looks right. You know what I mean? So in theory, this should just do exactly what we expect. But once we get here, it should just do a struct copy. I don't know how big these actually are. 8 does seem about right. And the data we can't inspect at the moment. Well, I guess I can. So that's the iHeader chunk, right? And these lengths and types are obviously garbage stuff too, because I mean, they're in the wrong endian. Although iHeader, wait a minute, shouldn't that have been reversed? I guess it would start on the low and go high. So I thought that would have been reversed. Let me just double check. Let me see something here. Here we go. I just want to look and see what happens here. Okay, so it does start out reading reversed because that packs it in reversed, and then this switches it to forward order. Okay. So that all seems good, right? And this, in theory, is just pushing on all of it. What happened there? Oh, well, there's nothing in here. All right, so I mean, that all seems pretty reasonable. We're going to do a write binary to the PNG out name, assuming that it works. We come in here, we loop through the chunks, we say what they are, we dump them all to the destination. And that seems fine. Like, what's the problem? Yeah, I don't get it. So that seems fine, but obviously I screwed something up. Let's take a look at what test PNG actually fails on. If I step in, what happened? Why can't I step in? Test PNG. Interesting. That looks like another bug. Look at it, creates a new breakpoint every time I click on that. Let me make sure that I didn't mess something up in my state of the debugger here. There we go. All right, so stepping into test PNG, I'm not sure why we can't seem to step to the first start there, but let's go ahead and see what happens when we try to load this thing. Here's the parser. It's going to consume one of these PNG headers. We're going to take a look what's in the header. That doesn't seem right. Is that right? So why is that parentheses null? I'm not sure what that's actually showing me. So something is up. It's like there's something at the front of the... Yeah. So I want to say that by default, our temp arena is probably doing padding of stuff. Is that going to be a... No, well, that shouldn't be a problem for us because we actually use the blocks the way that they should be used. So what's going on there? Why are we getting extra garbage at the front of our PNG there, folks? What's the deal there? Anyone know? So if I look here at this, I'm writing the PNG signature and somehow it's like the wrong size. What am I missing? I must be missing something. I mean, it looks like we're just taking the memory from the stream, allocating a chunk, adding it to the list of things to write. That's really it. And I don't see anything particularly weird going on there. Also, if I actually run this, sans test PNG, why am I not seeing the printout? Do you know what I'm saying? So what the heck? Oh. All right. Well, there's your problem. For some reason, this was a different. Okay. I'm not going to talk about that. We're just going to pretend that never happened. So for some reason, that was, I guess, only for things that wanted to annotate. We wanted to just dump the data. So we want really that. We want like a different function, which is just takes a data stream and puts it to a file. So that would have worked first time, I think, had we actually made the thing that actually converts a stream properly. That's pretty funny. All right, so I think now, in theory, oops, I got to run the full version. Yeah, I think now we're back in business, right? Okay. So now that we've got that moved in there, what I would like to do, you know what? I'd also like to go ahead and take test PNG. We had a run of this, I think, right? Did we? There it is. So if I run test PNG, oops, we're not in the right directory for that. So what's that? W handmade sources intro cutscene art. There we go. The thing that I wanted to mention is if we look at this piece of data here, we can actually now see the zlib headers are 80000 the way we write them. And they're 872603 the way they're written by somebody else. And so that should also be something that we can now look up in the spec and figure out whether we should be setting those things the same way. So let's start with that. Here we go. So if we take a look at these are the things that we were looking at, right? And here's that specification for the stuff that we should be seeing. Here's like some of the flag stuff and the Adler32 checksum as well, so on and so forth. So if we look in here, we see compression method 8 is the deflate compressor. That's what we thought. Compression method and compression info, right? So base 2 logarithm the LZM window of the LZ77 window size -8. Values of cinfo above 7 are not allowed. Cinfo is not defined specifically for CM not equal to 8. So that we can start decoding all of this stuff. The preset dictionary, the F level, which is the compression level, and then the check bits for the CMF and flag. When viewed as 60% short is a multiple of 31. Okay, so this is basically another checksum. There's just a lot of checksums in here. Why they didn't just put a checksum on the actual file, I don't know. They must have thought there'd be like weird like streaming partial checking cases or something like this. I'm not sure. So if fdic is set, I should print it immediately after the flag byte. So we don't want a preset dictionary identifier at all. So I think we want fdic to be set to 0. Looking at this, you can see that they also set it to 0, so that should be fine. F level, there's nothing. I think 0 is fine there too, because we didn't do anything. That's just advisory, right? It's just for recompression. So we should set 0 because if anyone looked at these, they should know, oh yeah, it's not compressed well. Because we're not, right? We're not compressing it well. So fdict and F level can remain 0, I argue. Okay, typing is hard sometimes. So I think we can leave those values as they are, right? And so when we look at these values here, 8 and all zeros, so is there anything we actually need to set? And I'm assuming that fcheck is the one thing we would need to set. So the compression info, the LZ77 window size -8, the base 2 logarithm thereof. So since we never enter an LZ, I'm hoping that that doesn't matter. So I'm hoping we can leave that as 0 as well. So I really think the only thing we really need is fcheck. And so what that says is CMF and FLG, which is this, right? I assume these are bytes. Yes. So these are the two bytes, and I believe they're these two, right? So CMF and FLG here. So I think this stupid checksum, which I think is stupid, is a 4-bit value, 5-bit value, 0 to 4. So I think that means 0, 1, 2, 3, and 4, or 5 bytes, I think. It says, when viewed as a 16-bit unsigned integer stored in most significant byte order, which is the opposite of what we would be storing it as, right? CMF times 256 plus flag has to be... What, like, why would they... What is the point of that? In what world would we need this specific thing to be checksummed here? There must have been an explanation, I guess. But I don't know. So what we need here is the additional flags value is 0, right? And the CMF value... The CMF value is just 8. Right? So I think the fcheck value in this case is just going to be 8 times 256. And then we need it to be a multiple of 31. So I think we're talking about this. Do we have a mod? Yes. So I think we're just talking about the fact that this is a 2 right now and needs to be a 0, meaning it has to be a multiple of 31. So 2048 mod 31, we need to change the value of CMF, which is it the bottom bit? Where is this? Yeah, it's the bottom bits. So we just need to add... We need to make this equal 31, so we need to add 31 minus 2, right? I think I'm not talking crazy here. So we need to add 29 to it. Am I right? Like, I guess. So I think the fcheck value is supposed to be 29? I don't know, man. So I guess they just thought that was a way... I don't know, man. That is some nonsense right there, but I guess they really wanted the ability to checksum just an interior portion of the thing. I don't understand why there's so many checksums in this thing. Like, I don't understand why you don't just have one. I guess they wanted to, like, no, I don't know. They must have had a reason. the zlib people weren't stupid, so they probably have a good argument for why in that day and age that was the thing you would want to do. But I don't know what it is. So anyway, that checksum should, in theory, solve the first problem if I'm interpreting that correctly, which I may not be. Which is to say that now that IDAT header should validate, which previously would not have done. We now need to start working on our CRCs, right? And we also need to put the Adler32 block in there. So the CRC check, in this case, I don't even know what it's supposed to be. So we're going to need some information about that, like what the CRC block, that's in the PNG, I believe. Because that's just a PNG footer for everything, right? Here. So here is a sample implementation. It says, so we, this is the code that we are supposed to use. So I mean, I guess this is fine. I would imagine there's probably a much faster way of doing this nowadays than what they're suggesting here, but I guess I don't know that we care about that too particularly much. So this is the code they're saying. It's a 256 byte lookup table, which you initialize once, and here is the initialization for it. I'm assuming we don't actually have a CRC table implementation at the moment, do we? Yeah, I don't think so. And then to actually use it, what we do is we look up into the table, we use that value that comes out of the table and XOR in the input. So this is basically like munge what we've got currently and then XOR in the input. And then when we're done, we do one final XOR versus sort of a mask here. I'm not sure what exactly the point of this is per se. But that's just the finisher. All right. I mean, if that's what we got to do, that's what we got to do. So here we go. So inside the PNG stuff here, I guess I'll dump this garbage in. And the CRC table itself, I feel like we could just run this generator and then dump it. Like, I don't know that we actually need to generate this every time. That seems like a waste of time because it's only 256 bytes long, so it should just probably be baked into the executable and leave it at that. So what I might say is let's go ahead and leave this if zeroed out temporarily, like so, and then this make CRC table, let's just actually do that in a slightly different way. Let's put this part in here and forget that part there. Let's call this stuff, and let's dump this to a file, right? So let's do this file, or let's just do this. So let's write to standard out all of these values for the CRC table. Each one of them is just unsigned long, so we should be able to do something like this, and just stream the data out that way. And what I could do is, if we do it like 16 at a time, I could do something like this. So we go through and, well, we could do that. So we can go through this whole CRC table and every 16 or so. Same way I was doing the other one. So every 16, I'll put in a carriage turn there. Something like that. Just to make it a little easier for us to cut and paste it. But other than that, I think that's all we really need, right? So let me go ahead and plop this into HH font, just right at the bottom, like so. And then I'm just gonna run this. Right, so I'm just going to run this and make this thing just write itself out. So here's a CRC table X that they claim. Yeah, I know it's unreachable code. Thank you. Fine. Stupid thing. Compilers are the worst. Okay, so let's go ahead and run this now. Oops, forgot the equals 0. Okay, so maybe 16 is a little bit aggressive. Maybe we want more like 8. And there's a nice table. If I go ahead and loft that up into here, then what we can say is like, all right, they want a CRC table. So here's our global CRC table. And there it is, right? And that way we don't really have to worry about it. And you know, maybe I'm even feeling like super squinky. So maybe I'm just gonna go ahead and put it in here and say, you know, maybe we want the full Monty there. So to just pad out the values so they line up, right? So in theory, that's the CRC table. Hopefully, who knows? So we'll put that out there. So now we've got the CRC table, and we don't have to include all this nonsense code in our application, right? It's just baked in. So then if we go ahead and do update CRC here, now we just need versions of these things. And that seems a lot easier for us to do because now we can just figure out what we're supposed to CRC and go from there. Now, there's a couple different ways that we can do this, and you know, we'll think about exactly how we want to do it. But I've got some ideas. So the first thing I would say is, well, you know, looking at how we're going to want to call this is probably a good idea. Also, if we want to just make this work right away, like we don't need this anymore, right? So this entirety of this code is just looking up into here, right? So now we can actually call the reference routines exactly the way that they were written. I just don't think I probably want to do that because I think we're going to find out in a second that we want this welded in a different way. But, you know, there it is. So that's what they're claiming they want the CRC to be, which is fine with me. I don't really care what they want their CRC to be. I just didn't really want to have delayed defer function called nonsense to create a table if the table is so short that I could just make it into the app, right? So when we actually come through here to write the PNG, what are we actually going to want to do? You know what I'm saying? So like, how are we going to actually produce this? So if I look at what's going on, there's a couple different places that this happens. And, you know, it kind of looks like, at least to me, the way that we might want to do this is say, okay, so there's going to be a range of blocks here. and we probably want to just have the CRC operate on a bunch of blocks, right? And so rather than doing this, what I probably want to do is something more like this. So like this. Maybe? What do you think of that? Too crappy? So basically what I'm saying is we mark where we want the CRC to stop, right? And then we just say like, okay, you know, the chunk footer CRC is, and we ask for it in big endian form directly so that we don't have to like reverse it every time. So we just say like, hey, there's a start CRC and an end CRC every time, and that's just like what we do, right? And then we can just write one routine that does it all, and we don't have to keep doing it every time. Maybe, I don't know. I also don't know what the heck we're supposed to do on the IN chunk, because I guess you just return the CRC of nothing. Like, I don't know. So this one's a mystery to me. Like, I don't know what the CRC of the end chunk's supposed to be. Is it supposed to be just a CRC of no input? Or is it just supposed to be 0? Or, you know, what? I don't know. So I guess so I don't really know. And I guess maybe what we'll say here is like, okay, look, if I pass you nothing, you're supposed to do whatever the PNG spec says to do with no data. I don't know. But anyway, that seems to me like the sanest thing, because then we can just use the fact that we were doing our stream out stuff into temp buffers to allow us to compute the CRC across it really easily without doing too much work. So then, you know, if we look at the CRC code here, right, I can just make that code do something sensible. So if we have, what is that CRC? It's a U32. Yeah. So if I then take the CRC garbage that we're supposed to be doing here, and I actually use this code for it, then what I would need to do is, so in here you could see like what would happen is it would just do nothing, like the len, it would do an update CRC of 0 if we didn't have any data, I guess, right? So I think what I want to do in nbig CRC is it will take a stream chunk that's like the start chunk, and it'll take a stream, and the stream itself well, I guess it doesn't really need the stream itself, does it? Because it just runs till the end of the chunks. So actually that's probably fine. So I think actually maybe we don't really need that. So it would just take a chunk and run to the end, right? So it's just going to do like while start chunk do stuff, right? So I think that's it. And then this code we don't really need. So this is the part that returns at the end. So I think we need to do this. The start of the value has to be this, I guess. And then the interior of the routine has to be this. Again, just reading the code. So I think they initialize with this value, they XOR out with this value at the end as the finalization of the hash. It's not really a hash, it's a CRC, but, you know, whatever. So when we then loop, what we need to do is this across the length of the thing, right? So this is what we're trying to do here. What I don't actually know is there any... I don't think there's any endianness. This is operating on a byte-by-byte basis, and the table is just using ulongs that were created on the same processor that it was written on. So in theory, we should be okay, right? There shouldn't be any problem here with endianness, I don't think. So my assumption here is we should be able to just say, okay, going through this, we just take the result value here, and we do this garbage, right? The rest of it is just taking whatever the buff pointer is and this n value, right? Which I guess we'll do this way. Seems okay. And so all we need to do here is just loop over the chunks. So stream chunk equals start chunk is valid, chunk equals chunk next. That gives me a loop over all the chunks. For each chunk, we just say, here's the contents of this thing, and here's the size. Oops. Right. And I think that just does what we want. And honestly, this doesn't really need to be this way. Just do it like that. Right? So I think that pretty closely mimics what they asked us to do. Is this a count? Yeah. So I think that works. And then all we really need is when we're outputting these things, we would need to know where the stream was. So what I think I might actually do is mark these. I don't know how I want to mark these, I guess is what I'm saying. If we look at outstruct copy, there's some issues here with how we might do this. But if you look at like outstruct copy, or outcopy, I guess I should say, it actually returns the data. And so what we really kind of need is a different way to mark this. I guess what I'm saying is like, maybe it needs to be that. You know what I'm saying? You know, it's like that. I don't know that that's great, but it seems like the only way to really make sense of this, I would say. That's all I got. So I don't know if that's actually computing it correctly as per the spec. We're going to have to go read it a little bit more carefully. But at least in theory now, that should be writing out things that have checksums in them, or the CRC checksums in them. But we don't actually have the Adler32 checksum yet. All right, so if we open one of these with GIMP now, that Adler32 checksum is still busted, so we probably are still going to get an error, right? So we're getting closer. Maybe you can see that we're actually getting, like, the Windows reader now does work, right? Well, we can't quite see it in there, I guess, but you can see it in here. I don't know if you can see it. It's actually showing the glyph. So we're getting closer to being able to use other stuff here, because there, so like that PNG read it. So we're getting a little closer, but we're still not quite there. And we know we need that Adler32 thing, which I have no idea what that is. So we've got to go look up what that actually is and find somebody who talks about, oops, what that means. All right, so Adler32 is what? This contains the checksum value of the uncompressed data, excluding any dictionary data computed according to Adler32 algorithm. The algorithm, the 32-bit extension and improvement of the Fletcher algorithm, is composed of two checksums accumulated per byte. S1 is the sum of all bytes, and S2 is the sum of all S1 values. Both sums are done modulo 65521. S1 is initialized to 1, S2 to 0. The Adler checksum is stored as S2 times 65536 plus S1 in most significant byte first network order. Okay. And that is of what? Of the uncompressed data. Okay, so we first want, when we write this out, this data has to be Adler32 compressed or marked. The uncompressed data is this data here only. So it would be this. Right? Whew. So in here, the Adler32 checksum of the data is going to be basically saying, hey, take everything from starting right after the nlen chunk, all of that data, because the uncompressed version of the data is that, right? I assume, but I don't know. So meaning it should include the no filter bytes, I assume, because that's what we fed into the thing, right? So, because that's like external to the zlib part of this. That's happening in the PNG side. So I'm assuming we want all of that to happen. And so now we've got to do this Adler32 nonsense, which is sort of vaguely specified right there. So if we were to do that, we now have the trunks coming in. And by the way, if we wanted to do this in a squinkier way, like a way where we're trying to allow a few more things to happen, you know, maybe, possibly, sort of, a little bit, kind of, we could also do this. Right? Because that'll allow you to pass in an end chunk, or one pass last chunk. You know what I'm saying? And so you just, normally it's set to 0, and then that'll terminate at that point. But if you wanted to stop on some chunk that was before the last chunk, just because you felt like it, you could. So that's nice. So let's read the spec. So it says here it's two sums. S1 is the sum of all bytes, and S2 is the sum of all S1 values, modulo 65521, right? So we've got S1 and S2. Initialized thus, modulo 65521. So we always take S1 plus equals the byte, whatever that is, right? We then do, I guess really we do this, right? Then S2 is this, and then it's stored as S2 times 65536, which is just to say the high order. That's just shifted it up, right? In most significant byte first order. So it's Indian swapped version of this. So at that point, what I'm not sure about is how we want to deal with these. I assume that these are Indian swapped. So I assume that this happens here. Is that true? I don't know. I don't know if the CRC is Indian swapped or not. So I don't know what happens there. I have no idea. I'll put it to doing. This is definitely Indian swapped. They said that right in the spec. So we'll go check the spec and see. It says plus S1, I assume. Yeah. So in theory, this is the thing that they asked for. And excuse me. In theory, that's the spec, right? Oh, whoops, that Indian swap is in place. So that's that. And now I guess we are attempting to comply with the spec fully. Oh, but we broke something. Maybe when we included that Adler32 checksum, we broke something. So I'm not sure what we broke, because we shouldn't have had anything strange there, right? But I guess we did. So we broke something there. I'm just not sure what. That's the only thing we changed, right? In the output stream, I think. Oops. So No, we broke something else here, it looks like. Or did we? Let's delete this whole thing. And just take a look. So it looks like we're still doing it right here with Liberation Mono. Let's delete all that and put the Adler32 back in that crashes our existing code. So it doesn't look like that actually affected anyone else's reader, though. Just ours. And off we go. So I guess I'm just not sure. How did we break our PNG reader? That's what I'm wondering. So when this does the decoding, it should stop on b final equals 0. So that shouldn't have really changed anything, right? Oh, no. I do know what the problem is. So in here, right, that chunk header length needs to include the size of the Adler checksum that we added. That's what has to happen there, right? In order to make that work right. There we go. All right. So I don't know how close we are to being compliant. Unfortunately, now I don't know how to get something that would. We need a PNG reader. Like this here tells us that it failed, but it doesn't say what actually was the problem. So it would be nice if we had something that would now try to read it and print out errors for us that said like this, here's your bug, right? Because I have no idea what those bugs would be, right? I have no idea. PNG writer test suite. PNG validator. Right? Like this seems good. And it has source code even. Oh, SourceForge. SourceForge is a bit dangerous. The fact that it has an Amiga directory makes me like it already. So we can say that about it. I'm going to go in here and say that we'll make a directory for it. And then what we can do is just, yeah, I mean, I don't know. Hope that we can build something like this to validate it for us, right? Is there also, oops, I don't really want to print anything. Just looking at this. Here's the make file. So maybe I'll start with this. And we'll see what we can do. Because I would like something that can tell me how the, what's broken, so I know what to start looking at. All right, so if we go in here and look at PNG check, I want to be able to build it, so I guess we'll just start by seeing if it builds at all. That seems easy. So PNG check actually looks pretty much good to go. So if I try running it on one of our exports, perfect. So it says that there's a CRC error, so we know our CRC code is wrong in the iHeader chunk, right? So there's a couple different things we might want to do. But first of all, so that's perfect. This is exactly what I hoped. So now I should be able to work through the code and get everything lining up properly. So the first thing I need to know is when we're doing our CRCs, we don't currently know whether we're doing them over the right information, right? So the first thing we should do is try to figure that out. If I go into the PNG spec, I should be able to get some information about that. So when we actually look in the CRC, it says the CRC fields are calculated using standard CRC methods with pre and post conditioning as defined by this ISO. The CRC polynomial is that it is initialized to all ones, which we did. The data from each byte is processed from the least significant bit to the most significant bit. That is baked into the table. After all the data bytes are processed, CRC is inverted, its one complement is taken. This value is transmitted most significant byte first. So that means this to do is fine, right? It is swapped. Practical calculation 0 plus a pre-calculated table, and here's the table. And that's the table we used, so hopefully we didn't do anything stupid here, but I think that should have worked, right? Yeah. So I think we're following that as well as we probably could. So now I just want to know, okay, so for the chunk footer, what's actually supposed to be in there? Yeah, where's some discussion of this? Let's just look at the first time. A 4-byte CRC calculated on the preceding bytes in the chunk, including the chunk type field and chunk data fields, but not the length, right? The CRC can be used to check for corruption of the data. The CRC is always present. Okay. So I think that is implying that if we go back and look at what we were writing there, what it's seeing is the IDAT, so for example, when we write the IDAT out, it's actually the chunk header that we want there, and we just want to skip the length field, but we want this other field, right? So the chunk header is actually the header that we wanted to be looking at in the first place. And so in most of these cases, we actually want to do this. And in all these cases, we could bake that into the nbig CRC, or we can actually have an offset. So in here, we want to skip the length field. So I'm going to say like, there's like a skip count or something that you do on the first one, right? And that'll let us compute that more conveniently there. So the chunk footer CRC in all these cases, there's one more here. It's going to be there, and this will look like that. So I think that's more what we're looking at here, if I'm not mistaken. So yeah, once we do that, that means our end big CRC has like a like a skip n value, right? And it would basically look like this. So the first time through, we're going to skip however many we should skip there, and then we'll stop, right? I think that works. I could put like a to-do here that's like, actually, here we go. Because we don't support this, right? So I think that would work. You know, I claim that it would, but I don't actually know. So let's try it. So if I now run this thing again, like so, what the hey? How did we, what did I do? That should not have changed anything, should it? That should have literally not changed anything, because we didn't touch anything at all in terms of what's getting output here, right? Like that doesn't really make any sense, because all we did was change the range where the CRC was actually operating, but we didn't actually write anything different, I didn't think. And that's even weirder, because now it's saying that it's a compliant PNG, according to PNG check. And it's compliant according to GIMP as well. So I'm not sure exactly what the problem is with test PNG. It doesn't seem to be crashing here. Liberation Mono 89. Let's just make sure it is crashing, right? Yeah, it's definitely crashing. So this command line crashes test PNG. So I should be able to run it. Oops. Under remedy. Shouldn't I? Oops. I guess remedy doesn't remember the command line there. Oh, it's just can't find the file. That's all. Oops. There we go. So I think we're roughly good now. That looks like it's doing fonts properly. So I think we're now in the clear and we can go to the Q&A. But that's what I wanted to do today, and so I just went a little... Well, actually, I didn't really go long because we started late. Technically, I have 20 minutes of programming left, I think. But we'll go ahead and go to the Q&A anyway. Ah! There it is. I was hoping that would work. I accidentally typed it into John's chat because the naysayer window was open. So I accidentally spammed his stream with :Q&A with exclamation point Q&A. All right, what I actually meant to say on my channel was Q&A. So now we should be good to go here, and yeah, and I think our PNG reader is also in good shape. I mean, reader and writer are in good shapes now. So now we should have full font compliance, and so next weekend we can basically just do a here is the final art pass thing, that rebuild our entire game's asset packs from sourceters and post those to the sendowl, and then everyone can be up to date. Somebody took my name and said, I thought there should be an error because the type was endian swapped before CRC was calculated, but apparently that is how it works. Yeah, I mean, I guess the way that it's supposed to happen is it's a CRC of the flat data, right? So it's supposed to go in MSB order, I guess. Hi, Casey. I think you would enjoy Revision Demo Party. Is that Demo Party? Revision Demo Party. There are plenty of people yelling Amiga frequently, and some of the Amiga demos and interests are very, very good. Yes, I bet I would enjoy that. What do you think are other fields to look into to get hired as a systems programmer other than the game industry? So here's one thing I will say, and this is just something that I was told recently. It may be completely wrong, although I don't have much reason to believe that it's wrong because it wasn't coming from an unreliable source. It was coming from a reliable source. So supposedly, according to my friends, Google et al. Have figured out that game programmers are better than their programmers and now are hiring them at very high salary levels, which apparently is creating problems for game companies because they can't really compete with web money, right? So from what I've heard, if you actually are a good game programmer now, if you just go apply for a job somewhere at one of these ridiculously wealthy web firms, they pay you really, really ridiculous salaries. The numbers I heard were shockingly high, put it to you that way. Like several orders of magnitude higher than if you look up what the highest salaries are on Glassdoor for Google. Those were the numbers that I heard. I don't know if it's true, but that's what I was told. And it's problematic for game companies in the area, apparently, retaining top people who just want some money. What do you think are other fields to look into to get hired as system programmers in the game industry? What does the align point for fonts stand for? The offset of rectangle. Yeah. So the align point for fonts was just instead of recording like where relative to the baseline the font is as a separate thing, we already had the align point, so we just used that. So the align point adjusts from baseline. Do you use any standard software development process while creating this game? I don't really think standard software development processes are good, so no. Depending on what you mean by that, maybe there are some we use. Like we like save the version of our source code every day and stuff like that. So we use some things that might be considered standard software development practices. I missed it during the stream. Could you show what an HHT font file looks like? Yeah, it's really straightforward so far. We may change this. When we go write the reader for font HHT data, we may want something else, so we can change that. You know, this really trivial for us to change. So this may not be what we actually want, but it's just what I initially did. Temp font. So if we, do we have less on here? More? There we go. So if we look at one of these files, what you can see is it's just a listing of the bitmaps and their align points for the font, plus the horizontal advance table, which is the n squared table of advance levels. That may not be what we actually want when we go to read it, and we might want something else. So we may want, we probably want a glyph count in there, for example, at the very least. But you know, we just want to make sure we could print something. So I would take this with a grain of salt. We probably want to, when we go write the reader next weekend to put the fonts together, we'll probably have a stronger opinion of what we want, and we'll go back and change the HH font to output exactly what the reader wants. But this was just to make sure we could output what we know. We know we'll need all this data. The question is just how do you want it formatted, right? Lucid Frost, are sampling profilers always strictly worse than adding counting points directly to the binary? I have trouble wrapping my head around the accuracy quality of sampling. I mean, I guess what I would say is they're probably always, you know, the likely true statement is they're always worse than a expert optimizer adding it, like doing instrumentation to their code, but they might not always be worse than someone who doesn't necessarily really know what they're doing adding stuff to their code, right? You know, an inexperienced optimizer may go in and add instrumentation to their binary that fundamentally changes the behavior of the binary in some kind of bad way that causes the profiling to not be useful. That can definitely happen. Whereas a sampling-based profiler is always the same badness no matter what you're doing. So it's, I mean, I guess I don't really know how to quantify those two things, but I wouldn't necessarily say that it's always strictly worse, because saying it's strictly worse assumes a certain level of competence and quality done to with how you're doing the instrumentation. And so like there's plenty of things on Handmade Hero where if we insert too many count blocks, we could easily slow things down in a bad way, and a sampling based profiler might be better, right, than doing that. So I think it's worth understanding that it's not like instrumentation is free, and so you can easily have an instrumentation case that's bad. And so I would encourage you not to really think of them as one is always good and one is always bad. I would think of them as sometimes one is a good idea and sometimes another is a good idea. And so probably the right way to think of it is running a sampling profiler is a good idea to try and tell you roughly where your hotspots might be. And then maybe instrumentation is a good way of then going and trying to attack those hotspots directly and getting really accurate data about just those hotspots. Does that maybe help think about those things a little bit? How does a sampling profiler work? Do they need to pause every thread, or can they take a snapshot somehow and then figure out where the program was? Um, so I'll be honest, I'm not sure what the current state of sampling profilers actually is. Um, I guess I don't really know. Uh, the old school way is you would halt the executable, you look at what the IP was of every thread, and you record that location, right? But they may have faster ways of doing that now. Um, because I'll just give you uh, um, I'll just give you an example. So if all you're trying to do is sample the instruction pointer, it's entirely possible for the x64 chip, and I've never looked, to give you a fast way to just grab the IP out of all the cores just without stopping anything, right? Um, I mean, that's an easy thing to imagine a chip giving you for a low-level way of doing a sampling profiler. So imagine a way of strobing the chip and just say, give me all your performance counters, RIP plus the performance counters that are currently active. Just give them to me right now. But don't stop anything. Just export it from the core, right? Like, treat it like a standard write. So all you're doing is using up a write, using up a cache line push, right? My assumption would be that that's actually what's going on now. That's my assumption. So I don't think they have to do the old way of doing things where it's like, uh, actually halt everybody. I would assume you don't have to do it anymore, but I don't know. I mean, I guess we could take a wild leap. Uh, wait. This is not. I want the full thing. Um, So let's see what we've got here. So I'm not sure I'll be able to find this fast enough a definitive answer. So I've never looked for it before. I mean, here's all the event counters, and these are just automatic. You can just enable these and you get events. But that doesn't really answer the question. So I'm not sure. I'm going to have to ask about that or read this more carefully. I don't know if there's any way to read out IPs at a fixed interval. Or just read out IPs period without halting. I don't know. I don't know. Yeah, I'm going to have to ask about that. So what does this thing do? Processor event-based sampling. This sure sounds like it, right? So the PEBS facility has been enhanced. Where? So tell me about this PEBS. What's PEBS? Yeah, I mean, this sure sounds like this does what you want, right? It sounds like you can just basically say, look, here's the counter that I want you to use, and when that counter hits a specific value, dump a record that includes the location of the IP. Does that, I mean, that looks pretty. That looks like this does that. Yeah. So I don't know because I've literally never looked at this section before, but that sure does seem like the processor has at least some support for not having to do an entire break of the entire executable to get that information. It looks to me like you can have records written out at the processor level based on performance counter triggers that you are looking for. So my assumption would be that a modern sampling-based profiler like VTune is doing that and not actually stopping anything in any broader sense than this interrupt. That would be my guess. How many are there game developers who actually care about performance optimization? Isn't most game dev just simple things? For example, maybe yeah. Okay, so just to be clear, I'm talking about like game programmers who actually know how to program games, like the whole game, right? So like engine programmers, not people who just write scripts in Unity or something. Those people are obviously not valuable because anyone can do that. The whole point of Unity is that anyone can do it. So yeah, those people are not valuable except in the extent that they make good games. But I'm talking about people who do like serious engine work, right? And this was just what I was told from people who had been trying to do game company staffing. They said that they were having trouble because it's not really feasible to pay people the same salaries that Google was paying them, which were like, even though the game engine programmer salaries are quite good, right? They're apparently much more worth it to go optimize their data center or something, and they'll pay you 4 times what you're making at a game company or something, which is kind of absurd if that's true, but that's apparently the case. And it makes sense, right? I mean, people who can make game engines can make anything. It's one of the hardest things there is. And DiffServe, it was much higher than $300,000 a year. So, anyway, I'm going to go ahead and wrap it up. All right. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you. As always, if you would like to follow along the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code. So you can follow along at home. I think we basically did what we wanted to do. So we can now take basic font files from any font that we want and dump it out into as if it were made as a series of PNGs. Ready to be imported into the game using the standard pipeline, which gets us out of the business of dealing with fonts pretty much at all. And lets us treat them as just standard art assets, and so we can kind of ship source assets to people who are trying to build the game at home, and just have one directory full of PNGs, and then you just use that with the source code and you're done. Well, and WAV files. So that seems good, and that's where I wanted to be at, and now we are. So next weekend we can focus on getting like a finalized asset pipeline and be like, here we go, basically we're done. And then from then on out, we really just have to think about things like how we want tag files and obstacles and stuff to come in, because we still have, like, inside the complete art pipeline, we still have lots of flexibility with how we mark things up. And so we should probably then start trying adding a bunch of stuff like ground cover, furniture, different outfits, hats, whatever. Like, we should just go through and try to implement a bunch of random stuff like that and use that as a way to fine-tune how art gets imported and marked up. And that will, I think, then get us to a part where we can sort of definitively say this is a good art pipeline now for Handmade Hero. We can be happy with it, and check that pretty major feature off of our list. That's about it. I'll be back here next week, I believe. I have to check my schedule, but I'm assuming I haven't posted the schedule next week, but I should. I should be here back next week to start on that. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.